What is a MOSFET? A MOSFET stands for metal oxide semiconductor field effect transistor, right? There are three pins to a MOSFET: a gate pin, a drain pin, and a source pin. Typically, you can activate or deactivate a MOSFET by applying a voltage to the gate pin. There are two types of MOSFETs in general. You have enhancement mode and you have depletion mode, right? Enhancement mode is basically when you apply no voltage across the gate terminal, the device doesn't conduct. And when you apply a voltage across the gate terminal, there is an increased conductivity. So if there's a maximum voltage, it'll have maximum conductance. Then you have depletion mode, where if there's no voltage across the gate terminal, there's maximum conductance, and any positive or negative voltage across the gate terminal decreases the conductivity. Once again, N-type and P-type. In a circuit diagram, this is what it looks like. You've got an N-channel MOSFET and a P-channel MOSFET. We'll go over the differences in a bit. But that's how they look differently on a circuit board. And what happens is, if I have a voltage applied over here for, let's say, enhancement mode, then I'll start to conduct. If there's no voltage, the voltage doesn't meet the threshold, there'll be no conductivity over here. If it's depletion mode, on the other hand, then normally I will be able to conduct easily, but the second I apply the voltage here and crosses a certain threshold, it'll decrease in conductivity and it'll be more and more difficult to conduct. So this is what a P-type MOSFET looks like. This is what an N-type looks like. It's just differences in the doping done to the actual material itself that changes it. We don't need to get into that. That's going to be discussed more in the semiconductors video. In a P-type MOSFET, you apply a negative voltage and the current flows from source to drain. And in a N-type MOSFET, you apply a positive voltage and current flows from drain to source. That's pretty much what a MOSFET does, and that's what it is. We'll go over some applications of it and a couple projects. But on the topic of application, there are two main uses. It behaves as a passive circuit element, so it's really useful. And radio frequency applications use MOSFET amplifiers really extensively. That's really prevalent in our circuit as well, where we also have a radio frequency amplifier.